Rightio. Okay, there's a few problems with 25K80s that have come up. It's not a big problem, only a few people have come across it. A bit louder, sorry, that's up. Okay, when the CAN-MIO servo kit came out, the idea was that it would be run the servos off a separate power supply, which was fine. This is Pete Brownlow's design. So the idea was that the servos will run off a separate supply to the PIC so that any supply, as servos turn on, they draw a fair bit of current, and this is causing problems with PICs. So the servos had a separate regulator. This is all fine. And all the initial servo modules are fine. They all ran off 5-volt PICs with and the servos. But as we can see here, we'll see a bit later, there's a problem if you're running your servos off a separate power supply, and it's got power on, it's powered, but your PIC isn't powered, then some of the current from the power supply feeding the servos does feed back into the PIC.
Can you show us the board, Bob?
We will.
We will.
Okay. This all initially happened when one member had a problem where his PIC or his CAN-MIO would be going back into slim mode. Had it all set up and running, fine, turn it off, come back next day, it was back in slim mode. They sorted it out, put it back into slim, have to reteach it. A few days later comes back, that one or another one's in slim mode. So after a lot of testing, he gave me the board, I changed every component, including the IC sockets, and it still did it. Changed different PICs, different regulators, couldn't find anything wrong. I then, what did I do? I then had some of my boards, I did the same thing. At the time we were using the Brown resonator, they'd come, the supplier were giving us slightly different resonators to the ones we had been getting. Also the software had gone from using a 4 megahertz resonator to a 16 megahertz resonator. So the PIC was running at 16 megahertz. But he also had some CAN-MIO outboards, which were also using the 16 mega resonator, which were also doing it. I then went ahead and read the EEPROM. I was finding that with my PIC kit, I found it had changed. I'd change it back to what it was initially, and it'd be back in FLIM mode. Right, here's a little demonstration of what was happening. There's no sound here, but you can see the yellow LED coming on and off. There's your power. So I set up an ACC8 with a 2.5 seconds on, 2.5 seconds off, continuous pulse to drive a relay to turn this on and off rather than sitting there with the switch. It'd be rather tedious. This is about 56 seconds long. This last sort of 15 seconds, you'll see that it changed to the green LED. It should be coming up about now. So I'm holding the phone doing this. Right. I mean, sometimes I do it before I even pick the phone up. There you go. There we go. Green. So, one of the things, I was also then involved with Ealing Road, with the Channel 5 Great Model Railway Challenge. And we used some of Barry's modules, servo modules. And after the program, we decided to keep the layout going, and we rebuilt it. He did some rewiring, turned it back on, the modules didn't work anymore. And again, I found that the CAN pan and all the CAN servos, I had to reprogram the PICs to get them to work. And one of the things, when it was initially designed, so you can see what I did find when I was doing this was that we had the C-bus power supply off, but the red LED, power LED was half lit, and the run FLIM LED was also on. And I thought, well, how can this be? And I chased it back through, and there was power coming from we had the accessory supply through here, down through there, back into the PIC, and I had about just almost 2.5 volts on this. And of course, the new PIC, the 25K80, can run down to 1.8 volts. Took that off, and I just put this link, I disconnected that, put that link on, and we haven't had any problems since. So there's several things we're thinking of here. I spoke to Pete about this, and he said, yes, you should not have any power on here if the C-bus isn't supplied, which, quite sensible really. But there's nothing in the instructions to tell people this. And really what he has done is he's fitted a relay in series with it. So if power's gone off,
we should have called this meeting the relay meeting.
Right. Yeah. So effectively, relay contact. So if power goes off here on J1, it disconnects the relay, so you're not powering that. But we also has it so that it's start of day. So you power up your C-bus network, you push your start of day button, it operates an ACC8 or another module, which then turns power on to the servos. Right. In all this testing I did, I tried increasing the value of C2. If I go back, this one here on the input to the 5-volt regulator, and that made things worse with the problem of the going back into slim mode. I then tried as I'd already changed the regulator, I changed it to every other component on the board. I put a 100 ohm resistor, where's my mouse gone? Down there. Across this C2, and that made things, it didn't go back into slim, very rarely or at all, which indicated that it was the power off sequence was causing the problem. But really putting a resistor across there isn't a fix for what you want. You can't have it loading it all the time. I then I changed the crystal or the resonator. I ordered a different brand of resonator, and that also seemed to make things better. But I still had the problem. It would still sometimes go back into slim mode. Pete did several different firmware changes, and then the last one, Pete Brownlow, as it's his firmware, what he did is in the PIC you can have, there's a quadrupler to make the clock go 4 times faster. So he increased it to use that, so then the PIC then ran at 64 megahertz, and the problem went away. But in theory, it should have nothing to do with it. And he couldn't understand why, but we had something going. We went to the blue Murata resonators, 64 megahertz, and all was hunky-dory. Right, okay, there's all that. I also tried on the MCLR, tried this little circuit, pulling the reset pin low early before power went off, and that was one of the other things that fixed it. So if I go back here, where's pin 1?
Well, you've got the circle.
Right, yeah, okay, there we go. How clever of me. So So I basically disconnected it from the 5, took that down to 0 volts and took the diodes and series resistor to here. So basically as this pin 1 would be still at a logic high for the PIC, but as soon as the voltage started to drop, it would, the 10K would then take it low, and that also solved the problem, but that really again wasn't a fix. But it helped indicate, you know, what might be going on.
Well, it's fairly obvious what's going on. The PIC is trying to run from a phantom supply coming in via its IO pins.
Oh, right. But even with that disconnected, I didn't have that powered at all.
Not at all.
Not at all. It still did it.
Right. With no power coming in?
No power coming in on J2, this one here, on the auxiliary input. Yeah. I only powered it from here.
Did you have that link in to connect it across?
Some of the boards I did, some of them didn't. I ended up with 10 MIO boards, all plugged in, all getting powered on and off, and trying different things. And you run it for 5, you know, I just wait till when one of them stopped. I made a note of which PIC, which board, which firmware, right, the whole lot. I went back to earlier versions of the firmware, the Servo 8 at 16 megahertz. It also had the same problem. So this is some of what we could see here is the power going off. So this is your 5-volt supply. The 25K80 has a 3-volt internal regulator, and that's why it's got that additional little capacitor, the V cap, to help regulate that. And that's the blue line here. And the purple line is the pin 1 of the, and you see it sort of drops quickly, and then there's a little knee, and then it falls off. And this is what I could sometimes see with the LEDs. They'd go off, but you'd see a little flash and then a drop again. I'd see this sometimes, the little green, that slim LED would flash on sometimes as the power went off, and it shouldn't come on at all. So the 2480 that we had been using in all the other kits can run from 2 to 5.5 volts, but the bore was set at 4.6 volts. The newer ones.
What does bore stand for?
Bore is brown out reset. Right. The 25K80, of course, it is designed to run at a lower voltage, and the CPU really at 3 volts. The highest bore you could set was 3 volts. The other, the highest bore we could set was 3 volts. So the problem is, what we were finding was that the resonators were stopping before it got to bore, this bore threshold, which would then, in this case really the brown resonators, would still be working, but they would go out of specification. So you'd get clocks that weren't synchronized. The CPU would get in and we think this is the cause of the EEPROM corruption, because it'll go off and it could do anything, and you don't know what it's going to be. One of the other things is that the CPU has different power settings for different frequencies. All the current software, it's set to HS1, which is 4 to 16 megahertz. Everything above 16 to 25 megahertz, it should really be at HS2. But I don't know, I'm just discussing with Pete as to whether he's going to update or bring out a firmware mod to increase the power level. But it made a slight difference, but not any significant difference.
Could we know what HS1 stands for, apart
It's
from high-speed one?
it's just the power level. It
It must be short for something, though.
High speed.
high speed. Yeah.
As
Okay,
against high speed two,
okay, got it.
Yeah.
as defined by microchip.
Yes.
Okay.
Well, this is. I read the EEPROM before I did. This is an example. I put a module into FLIM mode, then I'd read the EEPROM, and there we go. I think this byte here is the one that sets it in FLIM or SLIM, and then run the test till it went into back to SLIM mode, and I could see it changed. But why it had changed, we didn't
And why that one specifically?
Yeah, exactly. It's always that one. You know. So yes, as I could edit the EEPROM back into, or that byte back, and it would go back into FLIM mode.
I had a problem similar to this many years ago at work with an 18F device, an ordinary 18F.
Yeah.
And one of the things that we tried was when you have read all your E-squared, point the E-squared address away from anywhere that's actually used.
Yeah.
So that if, by some means, the CPU goes and does a unscheduled read of it or a corruption of it, it would actually corrupt one you're not interested in. I don't know if you've tried any of that. This is the thing, it might be worth looking at the code to see where is the E-squared pointer pointing at this time. If it's a simple matter of pointing it somewhere else, you don't care.
I got a feeling Pete or Dave Mc Cabe may have mentioned something like this, but it's up to Pete and and Mike. They're the other people who really.
Now, have you seen anything in the flash memory file?
Sorry.
Have you seen any flash memory?
Program memory.
Yes. I did a few. All the earlier tests, I hadn't looked at the flash memory. I just looked at the EEPROM. But yes, well, well, one thing that did happen with all these tests, with powering them on and off, I ended up with 10 PICs that were dead, you know, and you could sometimes you could program them, sometimes you couldn't program. Sometimes they'd program. You put them into the module. You put them into FLIM mode, but as soon as you do anything, they'd crash, or there'd be one problem or another. But about 10, because I was power cycling on and off, was it 20 times a minute for hours on end, and these things would happen, but some of them just didn't recover. And I did find in one of the recent trials that some of the program memory had changed, and the only way to fix it was to reprogram it with the PIC kit. Yes.
Is this just happening with your hardware? I mean, we've got C-bus all over the place. Is it only just happening in your locality?
No. Paul Townsend's had it with his CAN-PAN and running Ian Hogg's firmware. The other chap, MERG member in town, he had it with 3 of his 5 modules. Dave Mc Cabe's had it, and there's several other people who have also had it.
This occurred, didn't it, with Ealing Road?
Well, no, it didn't start. It all started back with the servo firmware before we went into production with the servo firmware, and we thought we'd cured it by going to 64 megahertz and going to the Murata resonators.
Right. This is the servo firmware on the CAN Leo.
Yes. It's the CAN Servo 4S is now running at 64 megahertz. If you got the N, it's still running at 16 megahertz. And I had it occurred more often with it.
Sorry, when Rob Thomas
described all of this at the Three Counties meeting. Barry, I remember saying, as long as you don't use the supplementary power in.
Oh yeah, I told him that. Yeah, this is what we did. This is what we went back to earlier on. I disconnected the.
And it still happened.
No, it didn't happen.
It didn't happen.
It didn't happen.
So provided you use the brown resonator.
No, the blue resonator.
Blue resonator, and you didn't use that separate power supply, that's fine.
Yeah, yeah. But or you put a relay or something in to stop the servos being powered, and you're getting feedback. Right. Yeah. There's several fixes. Paul's bringing out Townsend being the next journal, an article saying, you know, various fixes. One of them was to change the output resonator to a PIC. Oh, not to a PIC, to a ULN 2803 or the TDA FET version.
Yeah, so you're stopping the phantom supply chain.
Yeah, but all your signals are inverted.
Yes, they would be.
Yeah, but
It
won't. Yeah, yes. So as he's using Ian's firmware, he can invert the signal, which is fine. But for everyone else, you can't. So you'd have to change the firmware, right? So don't change your Resonet for a ULN if you're using the standard firmware.
That's easy. Two instructions at one point only to do that.
Well, someone's got to write it.
Could you not change the firmware and don't use a separate power supply?
Yes.
So, or you could just put a relay in to stop any power, and that would solve it.
Yeah.
Without changing the firmware or anything.
Yeah.
Basically, you've got to stop the processor from running when
Yes.
its own supply is not there.
Yeah,
Yes.
exactly.
Yes.
That's what it is.
Okay.
Right. So we did thousands of power cycles with and you know, it was all fine. So all hunky dory. Problem solved. Went into production, or so we thought. You know, but as you can see, as Eric Morecambe said to Mr. Preview, right. So we're now coming up to about 700 kits out there. Plus all the ones Pete's done. This is where we got back to Ealing Road, and I found that the CAN pan had also been corrupted. It also has a 25K80. The problem I found there was that I configured the switches for toggle, push button switches for push on, push off. I came back to it after several months, powered it all up, and they were in on-off mode. Now, I didn't do anything other than read and update the NVs, and they're working again. So what was in the laptop and what was in the PIC had changed. So I think it's not just the MIO, it's just all with 25K80s, and the CAN pan runs at 4 megahertz. So there's some investigation to go on.
Well, you have not mentioned the CAN sol once since you started talking about this.
Right, well, okay. The Brent, another member, the other day has had a problem, couldn't get his CAN sol to work. I went over all the solder joints, we did a whole lot of tests and different things. Then I said, just by the way, just update the NVs, which he did, checked the NVs, NV9 is the recharge time. And of course, when you just check them and click OK, it then updates them. And all of a sudden, it was working, right? Problem is how many CAN sols we sold. You know, it's a very, very small percentage, but you know, we've got the CAN MIOs, we'll get the CAN MIO out, we've got other modules with 25K80. I think that the MIO is probably going to be, there's more of them out there, and there's It's probably the way the firmware is written might have a slight, be more slightly problematical as to.
You mean more robust?
Or less robust than the other firmware, because it's running at 4 megahertz. Because one thing we found was that the oscillator on the CAN MIO running at the highest speed stops too early. So this is what I sort of spoke about earlier, power coming in here, down through and back into the PIC. Again, this is the AEL resonator. You can see as this is the 5 volts as it goes off. Your 3 volt internal regulator, and then this is your resonator. You see it tapers off as the voltage comes down. And I think it's somewhere just around here it goes a bit crazy. You compare it to the Murata resonator. It stops, the signal's not as big, and it stops almost straight away.
While the voltage in is still above the threshold.
Yeah. When I first did this, because when all this initially happened, I didn't have a digital oscilloscope. And this is my first attempts at learning to drive it. So some of the things may not be just exactly right. So, yeah, again, this is HS1 power. So this just tells you your supply volts, your 5 volt to the
voltage drain.
Yes. So this is again HS1. Right. When I did a lot of these measurements, it was from the output of the oscillator on pin 10 of the PIC. So it's actually one side of the resonator or crystal. Right. The problem is that the Crow probe was probably loading, adding extra capacitance and things. So what the values we see may not be exactly right. But so as the voltage, so there we are, we see it at 5 volts. This is at 4.5 volts, 4 volts, 3.5 volts, 3.3 volts, 3.2, 3.1. But the bore is 3 volts, so it stopped before it's got to the bore. So the PIC doesn't go into, and we think just at right that point there, between there and there, that's when your clock goes out of spec and you get EEPROM corruption. If we look at the, 3 volts, there we go. Murata, blue one, it's there. 4.5 volts, 4 volts, 4.3, it's gone. So it stopped well before, but it stops far more quickly and doesn't have, rubbish as it stops.
Have you tried just a crystal rather than a resonator?
Yep. So there's a CAD pan. Well, here's the CAN pan with at 4 meg at 2.5 volts. So it's working below bore. That's fine. Now these are all the people who have helped me. Now this is the EEPROM. This is a different bit of corruption in EEPROM. We also had discovered program memory corruption. This is Dave's post from this morning describing it. So basically he's going on to say that
So is he giving the solutions?
well,
because it says at the bottom there, the solution is a...
Oh, well, hang on. Page 2. This is his reply to Mike this morning, right? The solution is what we've found. Everybody happy? I'll move on. No, okay, right, good.
You're testing us at the end.
I am, yeah. So, one of the things, the current resonators that we have 30 PF caps in them.
The brown ones.
Well, the brown ones and the blue ones.
Right.
But in theory, to microchip's spec, they should be 15 or 20, between 22 and 15 PF. Yeah, or 27. Yeah, sorry, 22 for ceramic resonators, or between 15 and 22 PF for crystals. The current Servo 4S, yeah, it's again it's set, the power level set at HS1, and it's running at 64 megahertz. And this is a slide showing that to run at 64 megahertz, the minimum voltage here it'll run at is 3 volts. And so having to bore at 3 volts, yes, this is going to get sort of critical. And really, you need, you want it running at 5 volts.
So what it means is, if you're running at 4, the actual processor will run down to 1.8 still.
Yes, yeah.
Whereas putting it up to 3 volts, they both stop together.
Yeah.
And everything's right.
Yeah. So yes, the ceramic resonators need a lot more drive to get them to work, and this is one of the problems compared to a crystal. They said the brownout reset is max of 3 volts. There's a power on reset. That we checked that, it all seems to be fine. Pete did a modification to the code, so he brought the oscillator out on one of the pins. So then when I was doing the testing, the oscilloscope wasn't loading the oscillator, so we could see what the processor was actually getting. He also set the power level to HS2, but all my initial tests with HS1 were on the actual pin 10, so I'm hoping he might send me another version with it HS1 on RC3, so that I can do a comparison between the two, see how much of a difference it's actually making. Then this is the reset. This is from their page. There's a brownout resets down here, right? Is it? And
No, it's up further.
up the top, is it?
No, it's about halfway.
Halfway.
Yeah.
But there, right? Okay. So it's looking at the voltage coming in here into your OR gate. And then this is your MCLR reset pin 1. It also comes around here and into there. One thing I found that if you take that one low, the lead goes off, but if the brown lead but if you get a brownout, it doesn't. One of the two, or the other way around. So I think there's got to be some slight differences between what the two different resets do. And this is a AEL resonator, what it looks like at power off. And this is why.
So it still carries on.
Yeah, right.
Intermittently.
So the processor, the CPUs go, well, it's being, it doesn't know what it's doing. And this is the blue Murata one. It is a bit of a thing, but it goes, shoom, it will stop. And this is a crystal. So this is what we've got here, is that I've tried a crystal, and it's a much, a better, it's an improvement. So I'm hoping, Pete, we're just discussing the moment whether we should change the power setting to HS2. He may bring out an updated version, or may wait till the next software update.
Why don't we just put a relay in the separate power supply?
No, that's different again. Different again. It's different, yeah. Right.
One of the solutions seems you can change to a crystal.
Yeah, yes. This is, one of the solutions is changed to a crystal.
And now crystals are not much more expensive than
Well,
those.
that's it. They've come down in price a lot.
Probably hasn't got a place for the capacitors on the board.
Yes, that's the problem. So it means new printed circuit boards, right?
It's just the CAN-IO servo.
Well,
No.
It's the
No.
CAN
It's not, it's a lot of other boards as well.
It's
isn't
the
it?
CAN as well, John.
it's the
Huh?
20,
It's the CAN pan as well, you said.
yeah, and the console. But I've had one, because the other problem is, something will happen like this, and people will go, oh well, it can't be that. It must have been me. I must have, I'll just reset it. And this is what people have been doing, and then it's not till this. It gets to a point where there's enough people out there, they go, oh, hang on, that happened to me, and that happened to me. Like that, it all sort of comes together. I mean, it was the CAN lead test board, the lead test board. How many years had that been out? And then somebody went, hang on, row D is actually row A. It's been mislabeled. And there's been a few other things like that. I mean, like even when we put out the first circuit diagram of this, we had R7 and 8 on the leads, back to front, But we'd checked it, everybody checked it, It wasn't until someone went, hang on, I'm testing it, and it doesn't line up.
So sorry to interrupt you, Rob. Is the intention that Pete Brownlow and Mike Bolton will have to change the firmware in order to not have to change the PCB?
No. There's going to be there have to be several things. There probably have to be a few minor firmware changes, right? Plus, with the CAN MIO, Pete has done has altered the PCB. So, we might, if we're going to go over to crystals, and then he's made space. I'll get to that towards the end. Okay. So this is the Brown resonator at 3 volts. It's a higher power setting, so it's still going, as opposed to before it had stopped at 3.1 volts. So that's one thing. Down to 2.9, 2.8. Then the blue one, this is the problem with the blue one. In fact, the brown one works better, but it's that. So then the Murata one at 2.8 volt is stopped. So we can't really use for that. But if we use a crystal, it's fine. There's a crystal at 3 volts. Now, did I do these? I can't remember whether this was off RC3 or off the thing. So these are the current ideas for if you've got a CAN servo. Fit a relay in series with J2.
I'd be excited to use the FET for that.
Or fit, you could whatever. Some mechanism to stop it. Fit crystals. Now the problem with just fitting you can't do it. This is going to be a bit difficult to see. Well, there's the crystal, right? But it is very close to that capacitor there. This capacitor. So, and it's got a metal. Right. So this capacitor, the metal case of the crystal, will short to the pin, which is the internal voltage regulator of the PIC, or to the other end, which you can't see, that down there's the resnet for the external pull-ups on this J3. So you have to space it a little bit off the board. So what I've done is just used a bit of strip board, cut down 3 holes and took the copper off, and so it's just lifted it off the board, a millimetre or 2 for the moment, for testing, right? But if you've got these boards and you want to fit a crystal, then you're going to have to do something, or Howard can knock up lots of little spaces. So.
Could you put
these 3D printer?
underneath?
Sorry?
To upside it underneath.
On the flip side of
You
the board.
still have the problem of the can hitting the solvent pad.
Yeah, you still, yeah. And then, so what I've done, so there's your crystal, but there's nowhere to put your capacitors.
That would go probably on the side usually.
Right, so there's the capacitors on the underside of the board. There are 18 picofarads, I think. There. I'm trying to do this. There they are.
You said that the case of the crystal can short out on the capacitor.
Well, it's the leg of the capacitor, or the pads.
Is it possible to cut off a little bit of the, because the base seems to be sort of a bit like a top hat in that it's got a
Yeah, no, you'd have to, no.
Rob, are the pins of the crystal
They're underneath.
resonator, are they deep enough to be able to raise it onto a...
Yeah, but they're like this long. So that's why you can raise it up. A bit like your resonator, same sort of thing. But, right. Okay, so the other thing we can do is fit another little device called an MCP 111450, which is a voltage monitor IC. It's a little 3-pin thing that monitors the voltage, and when it goes low, you connect that to pin 1 of your PIC, which is the reset clear. It takes it low, stops the PIC running.
So you do that before the supplier's drained away?
Yes. So I've got a surface mount one, which I put on a bit of strip board, which is soldered onto the, and there it is, just there. And there's a little chip resistor just there. I think I've got it, a 1K. There you go.
Yeah, those small ones, when they fall on the floor, you can't find them.
Oh, it's when you go, and they go, dink! So this is another fix. So you can just make these up and plonk them onto your existing in-circuit serial programming pins header.
Does that work better than...
No. The idea is to fit a crystal and one of these. Sort of belt and braces.
So it's crystal and one of these?
Yeah, belt and braces.
I'm still going for a relay here, Rob.
No, relay, you need a relay as well. If you're going to run your servos from a separate power supply, then you put a relay in.
Just a minute. The relay is useless for detecting power off because it operates so slowly. So by the time the relay is operated, you're in the danger area. You've been into the danger area before the relay is operated.
But this would have already set.
That would sort it.
That would sort it. Yes. So there's.
So those fixes that you put up, those 4 fixes, they're not independent of one another. You've got to do them all together.
No, I mean, if you've only got 1 or 2 servo boards, right, you can run, and you've got a standard MERG 5 amp power supply. Just don't power it via J2. Just put link 2 on, and it'll be powered off the same main C-bus stuff. It'll be fine. It's only when you get up to 10, 20, 30, when you power it up, all those servos go, oh, I want half an amp. If you've got 8 servos on 30 boards, there's 420 servos all going, I want half an amp. There's 120 amps all of a sudden. So you use a relay and bring them on in stages, so you're not killing your power supply. So Paul Townsend's bringing an article out in the next journal where he does suggest these fixes and also this ULN, but you can't do that if you use your standard servo firmware. Right.
Sorry, can we have one meeting, please?
Right. So this is basically fit your relay in series with your J2. And you can either power, where are we? Either take this side of the coil down to an ACC8 and use start a day and turn it on. Or if you haven't got to do that, if you just wire it back across to here, if this power goes off, then that's going to drop out and it should have the same result. So this is where we can see here. This is where the resonator should go, and this is the V cap. The problem is that the top of the crystal comes right over to here and right down to right just there. It's bigger than the resonators we're currently using. So you do need to put some, it doesn't need much, but you will need something, so you're not going to short this pin via the can to that pin as well.
Just relay the board.
Well, yes. So, all right, here, there's a, there we go, that's it, same thing.
Could you hold that picture a moment, because I've got a query about it. I'm piddling hard to keep up with this, because I've never built these modules. That little board, printed circuit board with something on top of it.
That one, yeah.
What is it sitting on? Is it another relay underneath it?
No,
Okay.
It's here it is here, I'll pass it around. It's your in-circuit serial programming connector.
Okay, it's a connector.
Yeah. It's the normal pin header.
Yeah, okay.
That we use.
It just happens to have the clear pin on it.
Yeah.
Connected.
Yes.
I'm with you now. It's just
Yes.
that looking from the view on the screen, it was just a blank block, black something or other.
And the thing that's not showing is the relay which is in a separate power supply if you're going to use it.
Yeah, it's somewhere else. Off the board or next to it, wherever you like. Right, so that's a picture of it there. So Pete's thought what he might be able to do, the PIC has a facility to monitor its own voltage, a bit like as for the brownout, but write his own software so he can set the bore, write his own bore to set it at 4.5. But at this stage, it's going to take some time. It's not straightforward, so it's when it's around to it.
If that's only a startup, it's not going to affect turning off it. Yeah.
Sorry?
So if that's only a startup, it won't do anything on the...
No.
Start a day. What Keith's saying is that only affects start of day.
No, not start of day.
Start the processor.
It start, yes. The another thought is to move to a 25K83, but again, all the code's going to have to be rewritten.
What's different about that processor then?
It doesn't have the VCAP, doesn't have the internal regulator, and all the registers are in different places. But apart from that, and everything else is different. That's it.
What about writing in another bullet point, which is to rewrite the instructions? Because somewhere you've got to have a relay.
No, you don't.
It's okay. No, it's fine. That's fine, John. I've written some things. There's some. It'll be out there.
So that we are telling people. You've got to have this.
Yeah. Depending on what you're doing, but it's all sorted.
Are those options, or have you got to do them all?
Well, you can do as many or as. It depends on how much. If you're having trouble, with your module going back into slim mode or corruption, then you want to try and do what you might as well do all of them. That way it's.
I wasn't asking the question as somebody who's already got boards that I need to sort out somehow. I'm talking about the ongoing
issue
offer for the kit.
Right. Okay.
I would suggest that we PCB your reset device, so supply that as a thing just to plug on.
Right, okay. Well, Dave Mc Cabe has actually made some PCBs. He's ordered them from China.
It separates the crystal from the...
No. It's
always speed for it by stopping the processor immediately.
Yes.
Right, okay.
Right.
Can I ask you, if that works,
Yeah.
which is logically it should do,
Yeah.
basically the turning the oscillator off by force, effectively, like
Well,
pulling
the oscillator actually keeps running.
pulling the reset,
Yeah.
then if that actually solves the problem, we shouldn't need to do the other bit.
Yes.
Well, yes. Yeah.
Otherwise, it isn't the problem we think it is.
Yeah. Well,
Well, I suspect it's due to that particular chip's problem with two levels of power, basically.
yes, yeah.
Because it's got its I/O at 5 volts, and it's got its internal functioning at 3 volts,
Yes.
or 1.5 or something.
Yeah.
And that always screws things up in my
Yeah,
mind.
yeah.
I mean, I like a 5 volt machine that works at 5 volts if you can get.
Yeah, yes. Because the older PICs all ran at 5 volts.
Yeah.
And if you test, the older versions with a 2480, and you've got a separate supply, there is 2.5 volts on them as well.
Yeah.
But because they need a high voltage to operate, to run, it's not a problem. They just won't run. The EEPROM needs more higher voltage to do anything, so we've not had the problem.
Rob.
Of course, we've gone to the lower ones.
Rob, I don't think anywhere in any instruction that I've seen anyway, that it says if you use more than one of these, or if you use up to this amount, you're okay.
I think Pete's got a few things in the software wiki with CAN servos and things. Yeah, there's a few. Look there. But I think the sort of longer term is, as crystals have come down and they're cheaper, we might be moving to crystals, or the producers. So this is a board that Pete's done. Oh, sorry. Okay, Ralph, good note. Take care, mate. So he's made space here for a crystal. He's moved the capacitor out away from the, and he's put space here for 2 capacitors. He's also moved the LEDs over to here. The Flim and Slim LEDs. And he's fitted the space here for the TO92 version of the MCP, reset circuit. And there's a 1K, where's that gone? Where's my mouse gone? There it is. It's probably the 1K there to go back to the pin 1 of the PIC. That's another version of it. Oh, I've run off the end. There you go.